Alright, hi guys. I did not want you to miss anything even though I'm out of town, so I am recording this lecture so that you can see it. You will have to kind of interact and pause to take time to work, but let's review what we're going to learn. What I'd like you to do for your warm-up is go to page 27 in this book. It's over in the bookcases behind my desk. Oops, whoa. And if I go to page 27, I will see problems. These are like review problems on how to measure. So you should be able to answer number 5, number 6, and number 7 about how to measure on a ruler with accuracy and precision. If you get confused, you can turn to page 15 or 16. Page 15 was about precision, accuracy, and resolution, and page 16 had a little reminder on how to measure with a ruler. So you can refer to that for support. Then this was just the quote. I got a good quote from someone named Ko, and he said that the only things that start on time are those that you're late for. Doesn't it feel like class always starts slowly until that one day that you're late and then you missed something important? I don't know, an interesting quote, I thought. So right now, we're going to be working on that last essential question. How do we accurately convert from one unit of measurement to another? We already finished this previously, but we'll keep practicing that all year. So now you can turn to page 11 and 12 in your book after you finish the warm-up. So pause the video if you need to, and read page 11, oopsie, oh my gosh, and read page 12. These are about the metric system and something called SI. So I want you to read the book. So pause the video, read the book. Then get on your tablet and you will find these links. This is a good website about something called the SI system of measurement. And that I would call like a level 1 reading. This is more like level 2 if you want more information. And then everybody should also read this link. It's got prefixes and their etymology. Where did the words come from? What do they mean? So I want you to definitely read these two, and then maybe read this one for more information. While you are reading, take notes as you read in your physics notebook. What are some common SI prefixes? So copy the figure 1.7 from the book. So that's probably on page 12, right here. This is figure 1.7. Copy this in your book, in your physics notebook. You'll need that. Put a nice big title on it. We'll use this all year. Also, what are the 7 SI-based units? The website called Essentials of the SI has that information. So copy the table 1 from that website. Also, why do scientists use the metric and SI systems? So when you're finished reading the book and the websites, you can answer this in your own words. You'll probably want a paragraph, and in fact, I know you want a paragraph. This is a paragraph that I will assess. Are you using the academic vocabulary that's on that blue chart on the wall? Accuracy, precision, significant, figures, digits, metric, measurement. Use your academic vocabulary. Capital letters, periods at the end of sentences. Don't make your paragraph one giant sentence. Smaller sentences. Can you have a topic with evidence to support your claim? So I'm grading this for your English writing and your physics understanding. So hopefully you've read all that, right? If you haven't, go back, pause the video. But now I'm going to review like you've read. So SI stands for the Système International des Unités. It's in French, and I have no idea how to pronounce it in French. Maybe somebody in your class can tell you how to pronounce this in French. But it's a system that they developed in yes, Paris, but somewhere in France. And it's an organization, and scientists around the world recognize this system. So in French, we have the units of base of System International, right? The International System of Base Units. This is mass, which is measured in kilograms. Length is measured in meters. Time is measured in seconds. Temperature in something called Kelvin. The intensity of electricity, the electric intensity, is in amps or amperes. A quantity is in something called moles. You'll learn more about that in chemistry, not this year. And also the luminescent intensity. That's in something called a candela, or a candle. We won't really be using that this year either, I don't think. This is your metric prefixes. This is so important. Important for the rest of your life. So important. When you have something that's 1, well, hey, that's 1. That's easy. But you guys might be familiar most with the ones that I put an arrow next to. Like, you've probably heard of a centimeter. A centimeter is 1/100th of 1 meter. So this was a meter. A centimeter is 1/100th. It is 0.01 of a meter if I divide it into 100 parts. Another way to write that is actually 10 to the negative 2. We're going to learn about this column later, but I want you to focus on this column here. Millimeter is 1/1000th of a meter. Micro we will use in this class. That is 1,000,000. A nano is a billion, really small. But we will be talking about things that small in this class. We'll also be talking about big things like kilometers or kilometers. That is 10 to the 3rd, which equals 1,000. So there are 1,000 meters in 1 kilometer. We might use mega also. Mega means there's 1,000,000 meters in 1 megameter. So you should already have this copied, but probably in a nicer format in your notebook. So the question is, how do we convert? How many micrometers are in 1 meter? So I want you to copy this using the same style that I use. 1 micrometer, that's equal to 1 meter. 1 meter. Well, there's 1,000,000 micrometers in 1 meter. Let me go back and show you. Here's micro. That's 1,000,000. That means there are 1,000,000 micrometers in a meter. But now I can cross out meter, and I get just 1,000,000 micrometers. So on your paper, put X, cross out the meter, and now the only unit you have is micrometer. But how many meters are in 1 micrometer? Well, there's 1 meter per 1,000,000 micrometers, and now I can cross out micrometer. My unit left is meter, so I can say 0.000001 meters. And that's what I wanted. Please notice that when you use my style, this all works out perfectly. I wanted to know meters, right? How many meters? How many micrometers? There's my micrometers. So, when you're setting up your equation, make sure that you can cross out the meters. If this was meters, put meters in the denominator. If you want micrometers, get micrometers in the numerator. This was the opposite. I wanted meters, so that's on top. I wanted to cross out micrometers, so I put micrometers in the bottom. These you'll have to do yourself. So pause the video and copy these, use your notes to solve that.